Hello everyone, and welcome to section 7.4, Solving Logarithmic Equations and Inequalities. So it's going to reign true, especially starting now, that if you're ever stuck and unsure of what to do, rewrite it into the exponential, and usually it'll be at least a little bit easier to see what you might have to do. So I'm looking at this one, and it says, solve log base 8 of x equals 4/3. Well, I'm not quite sure what to do that, but let's see what happens if we rewrite it. So we've got a base of 8, exponent of 4/3 equals my argument of x. Oh, well, I can simplify that. I've got the cubed root of 8, which is 2, and then so that fourth power equals x. So 2 to the fourth is 16. So 16 is my answer. We have a property of equality for logarithms. And really this is just a fancy way of saying that that same property that we had, that if our bases were the same, our exponents are the same, reigns true for if our bases for our logs are the same. The only thing you have to be careful of is that your overall simplified argument cannot be negative. So do at least make a simple spot check to make sure that your argument, when you plug back in your x, is not negative. So let's take a look. So I see that my bases are the same. We won't get any that have the bases that are different yet because that's a whole different type of way of solving it. So I'm just going to set my arguments equal to each other. So I've got x squared equals negative 6x minus 8. You guessed it, it looks like we're going to have to factor. So x squared plus 6x plus 8 equals 0. I need a product of 8, sum of 6. That's going to be 4 and 2. So x equals negative 4 or negative 2. Let's check and make sure we don't get anything negative. So in both cases on the left I'm okay because I'm squaring. If I plug in over here, I've got a negative times a negative, so I've got positive 24 minus 8, still positive, and a positive 12 minus 8. Still positive. In both cases, I am all right. So both answers work. The exact number isn't as important as just pretty much making sure that I'm still positive. If I really want to double check the number, I can, but if I feel confident about the mathematics that I did, you'll be okay. Let's take a look at this one. So, again, bases are the same. So, I can set my arguments equal to each other. X minus 3 equals 2x. So, I'm going to subtract over x. And negative 3 equals x. Well, if I plug it in over here, I have a negative argument. And if I plug it in over there, I have a negative argument. Because I can never take a number to an exponent and get a negative, both of these, the left and the right, show me that I actually have no solution. That x equals negative 3 is what we would call extraneous solution. It's an answer, but it does not satisfy my actual problem. Now when I have inequalities, I do it the same way as I did with the exponentials. My bases are the same, so I just pretty much drop my log base 7 on both sides. So I've got 2x plus 8 is greater than x plus 5. I'll subtract x, subtract 8, and x is greater than negative 3. In both cases, it doesn't look like I might get a negative argument because in both cases I'm adding something that's going to be larger than whatever my x is being multiplied by. So x is greater than negative 3 is my answer. Now if I have an inequality with logs and there's only a log on one side, I have to make sure that my x stays on the left when I go ahead and rewrite it. And then if it is a less than, we need to make sure that our argument is greater than 0 is part of our answer. So similarly to how when we had the radicals and we had a less than, kind of the same situation. So let's take a look. Log on one side, so we're rewriting. So I've got 6 to the third, which is 216. And then once I do that for this one, I'm done. That's my answer. My original problem was a greater than, so I did not have to worry about taking care of that argument being greater than 0. I've already got that taken care of. Now let's take a look at this one. Notice I do have a less than, so I do have to worry about that secondary case where I'm making sure that my argument's bigger than 0. So set that up already. I have my x, and then I rewrite the 3 to the second power. I just simplify that 3 squared. So my x is between 0 and 9. Now if I have something a little bit more complex going on in my argument, I do have to just stick that in for my middle part instead of just x. So I've got my lower bound because I have a less than 4x minus 3, which is less than the rewrite part, 5 to the third. So I've got 0 is less than 4x minus 3 is less than 125. Solve the inequality by simplifying everything. So I've got 3/4 is less than x is less than 32. And that is my answer. I only have to worry about it being terribly complex is if my argument is something that's other than x, and if I've got a less than. If I've got a greater than, not too much to worry about. So that's all I really wanted to look at. We'll look at a couple more examples in class, and I'll see you then.